Hey guys, today we want to take a look at 1 and 2 step equations. We're going to also take a look at fraction coefficients, and we're kind of going to pull it all together with 1 and 2 step equations today. Now, we've looked at these already, so I'm going to try not to be overly simplistic on the vocab, but I'm going to be very organized in the way I break these down. So as a reminder, our goals when we're solving for 1 step equation is to get the variable by itself. And basically, in order to do that, we have to get all the numbers on the other side. And we're going to use inverse operations. I'm going to write down the word inverse operations. That means we're going to do the opposite of whatever's happening to that variable. So first off, I'm going to go ahead and highlight the variables. The variables, we use letters as variables. So I'm just highlighting all of the letters here in this first couple sections. The next thing I'm going to do is I'm going to draw a vertical line. I'm going to go up and down right at the equal sign because that's kind of breaking our equations in half. So just like that. And it just helps me remember that I'm trying to get everything from one side to the other. All right. Now I'm going to start with number 1, and I'm going to take a look at that m that I highlighted, the variable. And what I need to do is I need to get rid of that plus 12 that's over on that side. I want that side to just say m. So I'd love my equation to be m equals a number. But right now I have m plus 12 equals a number. So in order to get the m by itself, I need to do the opposite of what's being done. Right now, m is being added by 12, so I'm going to subtract by 12. In order to do algebra, the whole key to the whole thing is that we do the same thing to both sides. So I need to go to the right side and do negative 12 as well. Now I'm just going to do a little math. 12 and negative 12 cancel out. 10 minus 12, if I use my calculator and I subtract 12, it ends up being negative 2. And that's it. I'm done. I got m equals negative 2. I don't care that it's a negative. All I care is that m equals a number. Now, if I wanted to check my work, all I'd have to do is take that negative 2 and put it back in place where that m was. So I'm going to try this. I'm going to rewrite my equation, except this time I'm going to use, instead of an m, negative 2. Negative 2 plus 12 equals 10. So I got a question. If I were to type in my calculator, negative 2 plus 12 equals 10. Negative 2 plus 12. So I'd get 10 equals 10. So that checks to prove that it worked. My answer is m equals negative 10. Negative 2. Next problem, I have g, except it's on the right side. That's okay. It's being subtracted, so I'm going to do the opposite. I'm going to add 9 to both sides. If I add 9 to negative 2, I get 7. So I'm left with g all alone. G equals 7. Now I can flip that around if I want. I can just say g equals 7 the other way. I need to check to see if it worked. Negative 2 equals 7 minus 9. If I do 7 minus 9 in my calculator, I get negative 2. So it checks out. Number 3. If we have number 3, I'm going to zoom in a little bit, make sure we can see it okay. If we have y right next to a number, if we have just a number sitting next to a variable, it's not addition. It's not even subtraction. The correct thing is multiplication. If it's being multiplied by negative 7, then in order to get rid of it, I need to divide by negative 7. I'm going to do that on both sides to keep it equal. Remember algebra, notice we have to do it to both sides every time. And if I do that, what I get left on my left side is literally just y. I divided by negative 7 to cancel out that number, so that's gone. On the right side, I actually have to do the math. So what's negative 91 divided by negative 7? I'm going to type it in my calculator here. I got 13. You should probably check my math to make sure. Negative 7 times 13 equals negative 91. We're just checking it. Did that work? If I multiply these two together, I get negative 91. So negative 91 equals negative 181. That works. Number 4, a over 9 equals negative 4. So what is happening to our variable? It's not being subtracted by 9. It's being divided by 9. So if I want to get rid of it, we do the opposite of divide by 9, which is multiply by 9. Now, some people want to go 9 times 9 is 81. Don't do 9 times 9. Those cancel out. But in order to be fair, we have to do 9 to both sides. On the left-hand side, we're just left with the a. On the right-hand side, we're left with negative 4 times 9, which is negative 36. Let's double check to make sure it worked. Negative 36 over 9, I'm just checking it just like it was, equals negative 4. Let's find out. Does that work? If you type that in your calculator? Yep, you get negative 4 equals negative 4, so it checks out. All right, so those are our one-step equations. We did addition, subtraction, multiplication, and division. So we've done all 4 of our basics. However, our next section, I want to take a look. What if we have a fraction in our equation? And those kind of scare people sometimes, having that fraction before it. Our trick when we have a fraction is to actually multiply by the reciprocal. And that's one tricky way that we can cancel out fractions. Now, the reciprocal means the same fraction except upside down. So I put the 3 on top instead of on bottom. And then, remember, it's an algebra equation, so I have to go to the other side and multiply that side by 3 over 2. Okay? Now, if I type that in my calculator, my left side, it does cancel out. That's why I did it. But my right side becomes 15. Well, that seems a little weird. So if you want to check it, what we can do is we can plug it back in. 2 over 3 times 15 equals 10. And if we type that in our calculator, we get 10 equals 10. It checks out. I'm going to jump over to number 6. Number 6 has 4 over 9. So what are we going to do? We're going to do 9 over 4. And we're going to multiply on both sides. On the left side, it would be just canceling out. That's why we did it. So we have W equals, and if I go ahead and do the multiplication on the right side, and I type in my calculator negative 8 times 9 over 4, I end up with negative 18. If you're suspicious, we can check it. So I'm going to go ahead and type it in. 4/9 times negative 18. If I type that in my calculator, I get negative 8. So I get negative 8 equals negative 8. Checks out. Number 7, multiply by the reciprocal. Notice that we have a negative 6/5. So I'm still going to keep it negative, except it's going to be upside down because the reciprocal would be upside down. I'm putting parentheses around my negative fraction because I don't want it to look like it says minus, okay? Because it kind of looks like it says minus 6 over 5. So now that I did that, on the left-hand side, I just have k. On the right-hand side, if I were to multiply those out, I end up with negative 10. To check my work, I do negative 6 over 5 times negative 10, and I check to see if I get 12. And so I got 12 equals 12 when I did that. So check, it all worked out. Number 8, multiply by the reciprocal. So I'm going to do 2 over 1, but that one's negative, so is this one. I need to do it to both sides, so I go over here and do negative 2 over 1. And on the left-hand side, they cancel out, and I'm left with m. On the right-hand side, when I type that in my calculator, I get 18, okay? If you want to check your work, you could say negative 1/2 times 18. And what you're going to get is negative 9 equals negative 9. Okay. Let's look at two-step equations, okay? So at this point, everything we've done is one step, even though we've had some kind of funky steps there when we're doing multiplying by a fraction. When we look at two-step equations, general rule is undo the addition or subtraction, and then undo the multiplication division. Go in that order. So the first thing we're going to do is we're going to get rid of that constant term. That's the part that doesn't have a variable, just the number that's hanging out by itself. And then we're going to get rid of the number that's on the variable. Okay? So starting with number 9, the first thing I'm going to do is I'm going to get rid of the constant term by subtracting 8 from both sides. When I subtract 8 from both sides, I have 6x left over because I didn't touch that part. It's still there. On the right-hand side, though, I get 42. Now, I want to get the x by itself, and it still has a 6 on it. What is that 6 doing? That 6 is multiplying. So now I'm going to do the opposite. I'm going to divide by 6. If I divide by 6 on both sides, I get x equals 7. Okay? Number 10. The first thing I'm going to do is not get rid of the 2. I'm going to get rid of the minus 5. The minus 5 is the easiest part to remove because I can just add 5 to both sides. Remember, I always draw a line where the equal is, so I remember which side is which. When I do that, I get 2x still. I haven't touched that part yet. The negative 5 and the plus 5 cancel out, but then it equals 16. Now I need to get rid of the 2 that's on the x, so I divide by 2, and I get x equals 8. Number 11. When I do number 11, again, I'm going to try to get the x by itself. The easiest part to do is the constant term. The constant term doesn't have a variable on it, so I'm going to subtract 9 from both sides. When I do that, I get, on the left-hand side, I get 4, and then on the right-hand side, I have negative 4x. I still don't have the x by itself, so I'm going to divide both sides by negative 4. And when I do that, to cancel out, I end up with x equals negative 1. If I want to make this look the right way, I can just flip that around because negative 1 equals x. I'd rather it say x equals negative 1. That looks a little bit nicer. Sometimes I just like it to be on the x to be on the left. Number 12, I need to get rid of the constant term, which is that 7. Now, it does say 7 minus, but that doesn't say that a minus 7. So what we're going to do to get rid of that 7, because it's a positive 7, is we're going to subtract 7. We're not going to worry about that minus that goes with a 3. Okay? So when I subtract 7, I do subtract 7 from both sides. And that leaves me with no more 7s, but I do have a minus 3x equals 27. Now I can divide both sides by negative 3. Don't add 3 there because we have to remember that is a negative 3 now that it's connected to that 3 and that x. So I'm going to divide by negative 3 on both sides, and I get x equals negative 9. I have 2 more examples for you. For number 13, we're going to go ahead and do what first? Well, we're going to add 7 to both sides. When I do that, the 7s cancel out, but now I have 16 over here and x over 2 on that side. From there, I need to get rid of that x over 2, that fraction. Well, remember that division is a fraction. Fractions are division. So what it really is saying is x divided by 2. So if I undo divide by 2, I need to do the inverse, which is multiply by 2. A lot of people want to go ahead and do something like 2 times 2. But remember, we're multiplying by 2, so it cancels out. And we get x equals 32. Number 14, we have negative 5 underneath there. But before we do anything with that negative 5, I'm going to remove this constant by subtracting by 8 on both sides. If I do that, I end up with 3 equals x over negative 5. It says negative 5. It doesn't say I'm going to subtract 5. So what we're going to do, that's division. That's what that line means. So I need to multiply both sides times negative 5. I'm putting my negative 5 in parentheses. That way I don't think it says minus 5. I want to say, nope, that's a negative 5, not a minus 5. I'm multiplying by that on both sides so that on the right side it cancels out. On the left side, if I type it in my calculator, I get negative 15. And the x is all by itself. But I do want to switch it so the x is on the left, so I'm just going to flip that around and say x equals negative 15 that way. It's still right the other way. I just like to have the x on the left side. Number 15, I want to get rid of the plus 22 first. So I'm going to subtract 22. And that leaves me with 3 over 5x equals 6. Now, I have a fraction in front of the variable. So what I'm going to do is I'm going to multiply by the reciprocal. That means I'm going to multiply by 5 over 3. I have to do that to both sides, so I'm going to go over here and multiply by 5 over 3 as well. Now, on the left side, it just cancels out. That 5 over 3 and 3 times 5, they make each other go away. On the right-hand side, if I type that in my calculator, I get x equals 10. Number 16, I'm going to subtract 1 first on both sides of my equals. And if I do that, I get negative 8 because it makes the negative 7 even more negative. On the left-hand side, I get negative 1/3 x. Now, I have a fraction in front of my variable. So I'm going to multiply by the reciprocal, but my reciprocal is also negative. It doesn't make it positive. My reciprocal is just upside down. And then I need to do the same to both sides, so I'm also going to multiply by negative 3 over 1 on the right side. On the left-hand side, those cancel out. That's why I did them. And that gives me x equals, if I do this in my calculator, I get 24 for my answer here. Okay? Guys, that's a quick overview with some practice of two-step equations. One thing you can do for me before you wrap up these notes is I want you to notice that I did not check number 9 through 16. So I didn't go back in and plug in my answer to do any of them. I'm going to do it for one of them because I want you to go back and do it too. So even if you have to do it over on the side, but if you could go ahead and say 6 times, and take the 7 we have down here, 6 times 7 plus 8. And I want to know, does that equal 50? If you type this in your calculator, are you going to get 50? And that way you can check to make sure I didn't make a mistake here today. Check each one of these and then let me know when you got that done, okay? I'd love to know how it all came out.